Okay, density. You've seen density before, probably in elementary school. So density equals mass divided by volume. It's basically the mass of a substance per unit volume. It's a ratio of the mass to volume in a substance. Typically, the base unit in this class, we're going to use grams as our mass. The volume could be liters, could be milliliters, or centimeters cubed, which is the exact same thing. We use density as a conversion factor for a substance to go between a mass and the volume of that same substance. We'll do some examples in a little bit. The density of liquid water is 1 gram per milliliter. 1 milliliter water weighs 1 gram. Okay, the density of an object does not change. It's what we call an intensive property of matter. It doesn't matter what size, shape, or mass of that object you have. So there's a couple pictures of copper. The mass to volume ratio is exactly the same for both, so the density is the same. In your math class, when you found volume, you took the length times the width times the height, and it was almost always a cube. Sometimes we have to find the density of an irregularly shaped object. So I'm not going to read all of those steps to you, but essentially you put some water in a graduated cylinder, you record the volume, you add the object, and the volume goes up, just like when you get in the tub, and then you subtract the difference, and that's the volume of the object that you dropped in the water. Okay, let's do a density calculation. A certain solid has a volume of 35.7 cubic centimeters and weighs 85 grams. What is the density? I would like you to pause the video, work that out, see what your answer is, record it to the correct number of sig figs, and then we'll check your answer. Okay, welcome back. The correct answer is 2.4 grams per cubic centimeter. Hope you got it right. Another one. A liquid fills a graduated cylinder to the 45.6 milliliter mark. The empty graduated cylinder weighs 26.5 grams, and when it is filled with an unknown liquid to the 45.6 milliliter mark, the cylinder and the liquid together weigh 70 grams. What is the density of the unknown liquid? Pause the video, solve the problem, record your answer to the correct number of sig figs. Okay, welcome back. I hope you got 0.954 recording your answer to 3 sig figs. One last problem. If the density of gold is 19.3 grams per cubic centimeter, what is the volume of 200 grams of gold in cubic centimeters? So we have 200 grams of gold. I'm going to put it over 1 just so everybody knows that it's in the numerator. And we're going to use the density as a conversion factor. We have 19.3 grams in a cubic centimeter. Grams cancels grams. So 200 divided by 19.3, and we get 10.4 cubic centimeters. Okay, sometimes when we're doing labs, we're going to have you calculate percent error to see basically how close your laboratory or experimental results are to what they actually should be. So percent error equals the experimental value minus the actual value divided by the actual value times 100. If you look at that closely, you realize that we are changing operations. So in the numerator, we're subtracting. You have to stop and round before you proceed with the division. You'll see percent error a couple different ways. In the formula that we're giving you here, if your error is positive, meaning larger than the actual value, you'll get a positive number. If you come in below the actual value, you get a negative number. And sometimes you'll see this as treated as an absolute value. So don't be confused by that if you do come across it. You just have to know, if you're treating it as an actual value, you have to know whether you're under or over. Okay, practice problem. A student weighs a beaker and records its mass as 46.21 grams. The actual mass of the beaker is 47.93 grams. What is the student's percent error? Pause the video, do the calculation, round for the correct number of sig figs, and then we'll check back. Welcome back. You should have gotten negative 3.59%, which means your answer was a little bit less than what the accepted value is. Another problem. A student measures the mass and volume of a substance and calculates its density as 1.40 grams per milliliter. The correct or accepted value for the density is 1.30 grams per milliliter. What is the percent error? Stop the video, do the calculation, and then we'll check your answer. Okay, welcome back. You should have gotten 7.7%.